And so up next we have Rob Manson as he gets his slides up with BuildAR, and then the awesome web.
Yeah.
So whenever you're ready, sir, take it away.
Can I just do a volume check? Oops. Yeah, that's probably good. Okay. So yeah, hi, my name's Rob. I'm co-founder of BuildAR. So BuildAR's been around for a while. We were the first web-based AR authoring platform released in 2009. And so we've really been working, trying to stay at the forefront of how you create AR content. And at the moment, the platform lets you do in-browser editing and creation, and then you can publish out to native applications or the GenAI platform. But what I'm going to do today is change the way you think about how you create augmented reality and how you'll be delivering it over the next few years. So our focus is really on unlocking augmented reality through web browsers, through the standard web. And I think a lot of people have quite a fixed view of what the web can achieve. And I hope through today I can really change your view of what's possible. So everybody here is really obviously aware of what augmented reality is, overlaying information onto your view of the real world. But AR is really hard to access. The leap to go from knowing that there's an experience somewhere in the world to actually experiencing it is massive. And there are these hurdles that you have to drive users through. So the first thing you have to do is explain to the user that there's something there. And as the technology gets better and better, more things become interactive. And so it's harder for them to know what is and what isn't. When you had QR codes and fiducial markers, it was really easy. There was a strong affordance. People could tell what to do. Now, almost anything is interactive. So first you have to spend a bit of time explaining to the user what to do. And then you have to tell them to go away generally. So you have to ask them to go to an app store and download an app. The majority of users don't have the right app installed to view the content that you're creating. So you send them away, and at each of these points there's a massive drop-off hurdle. And then they have to search in the app store and find the right application, download it and install it. And then depending on the type of application it is, if it's one of the AR browsers, they have to then search for the content in there, maybe do a visual search or even a text search. And most of those apps have a first use experience as well. So by the time somebody's gone, I want to use this, and they've gone through all these hurdles, and then often the end experience just isn't worth the effort that they've gone through. It's a value exchange. You have to make it worthwhile. And that's why over the years we've really found that this hurdle is the biggest hurdle that we face getting people to use things. And probably this payoff, the value exchange, is the biggest reason that you don't see a lot of return usage in AR. There hasn't been a lot of utility, and there just hasn't been a lot of repeat traffic. So our focus is on delivering augmented reality through the web and making it a seamless extension of the web itself. So combining augmented reality with the web and smart and wearable devices like this. So what I'll do is I'll play a video. It's got a bit of a brief introduction or an overview of the vision for that, and then a range of demos, and I'll show these different types of interactions in AR actually working in different browsers and on different devices, and then I'll end that with a great zombie impression. You'll see what I mean in a moment. Into full screen.
Stop. Just for a second. Think about how much the web has changed our whole world.
I broke it.
And how quickly it's grown to become the biggest audience available. Now imagine what's possible when you combine the web with augmented reality and make it available on all kinds of smart and wearable devices. Imagine what's possible when we bring the web out into the real world. If you're like us, then you live on the web. You love the latest technologies, and you can feel that there's a new revolution just around the corner. We believe that the augmented web is that new revolution. It uses the latest web standards to unlock augmented reality on smart and wearable devices, using any standard web browser. We've spent the last 5 years working on this R&D, and now you can try it out for yourself. We've already released the first open source portion of this project. with demos of rich, interactive augmented reality, working on all kinds of devices, including computers, mobiles, tablets, the Oculus Rift, Google Glass, and more. So say goodbye to begging your users to download restrictive AR browsers or plugins. Augmented web experiences all run in standard web browsers. You'll simply create your augmented web content using the next generation of BuildAR. Then embed it on your web page, just like any YouTube video. Then simply open it in a standard web browser, and it just works.
So I'll walk through some examples. This is a standard example of geolocation-based AR. It's running on quite an old Android device. Some of the things you'll see are a little bit slow in the demo videos. Usually it's because of the screen grab application running as well, so you can see that up in the top corner. So this uses the camera view from the phone, but it's inside a web page. So we just place the video in the background, and then in that we can use the sensors from the phone just like you do in a normal AR app, and we can float 3D content around. So here you can see I'm just floating a really basic purple cube. It's a standard sort of geolocation AR demo. But that exact same cube I can just put a texture map onto, so I can drop an image onto it. And that's just one change in the type of path that I'm mapping to it. But that texture can also be a video, so you can easily just change the image file to a video file, and it'll map that onto it. And we like to do the promotion of beautiful Sydney in the background. And you can float 3D objects as well. So there's just an OBJ file, I can drop it in the scene, and it's exactly this, treated exactly the same way as all the other objects. And I can do standard interactions with these. So if I tap on this, you can't see my fingers because it's screen grab. But you know, if you tap on it, then you can have all the standard sorts of interactions with scale, translation, and rotation. And so all of the different objects can interact in the same way. Again, I just tap on that, and the object moves and rotates. And any of these objects can be interacted with in exactly the same way. So the video plane, again, can do exactly the same sort of interaction. But taking those really simple, you know, animations, you can put them together and make the type of interactivity that you really want in augmented reality. And this is all just driven using JavaScript, and it's using the open source platform that we've released. So all of these demos you'll see are the same. So here I can just tap on the rocket, and using just 1 or 2 spins and a movement through space, I can launch the rocket and create some really good interaction. So that's just a simple example of GeoAR working inside a standard web browser on an Android device. So that's the augmented web running there. I'll move on to the next demonstration. And this one is using marker-based tracking. So it's using the JSAR toolkit, which is the older style AR toolkit tracking. And so basically it's doing the same thing, so we're placing a video background on the page, and the tracking's turned off at the moment. So there's a call to action at the bottom. It says there's a dog in this box, you'll see when I pan back. And when I turn on the tracking, it will start mapping the 3D object over the top of it. At the moment, the web browsers, the JavaScript libraries only support fiducial marker tracking, so this sort of tracking. But there's some trackers that will be released that do natural feature tracking this year, and we've got some great developments that we'll be releasing soon. So when I turn that on, you'll see the 3D model projected onto the surface. You'll see it jumps a little bit, but that's not because it's running in a web browser. That's just AR Toolkit tracking full stop. It's just the mathematics behind it is a little bit jumpy. And there's a call to action on top, so I can just tap on that box, and you can see the sort of really dynamic, interesting interaction we can create just with a few simple lines of configuration, basically, but it's just JavaScript. So it brings the balloon dog floating out of the box. So that's an example of image-based tracking. And again, running on that's a Nexus 4, that's quite a slow old device, which is showing the sort of performance you can get out of them. So the next demonstration uses a combination of different tracking approaches. So what you can do is you can really put together all of these different things, and it can be across devices and across users. I'll talk about some other examples of that in a moment. But so this uses the JSAR toolkit tracking for the fiducial marker. And then we also use the Leap motion controller. So the Leap motion controller is an infrared sensor. It does hand tracking. It's a bit like the Kinect but it just does your hand. And so from that, as you wave your fingers over the top of it, it'll extract the pose of your fingers in your hand, and you can do gesture recognition as well. So when I turn on the tracking, you'll see that we just project a video plane over the top of the fiducial marker. So it's just got a loop of some road running. Okay, that's going to be pushing it. And so there's a 3D object floating above it. And so what I can do now is I can use my hand over the leap, and the tracking from that is controlling the floating car, and then the tracking of the underlying object is controlling the video plane. So you can create all sorts of interactions that mix and match these different technologies. Here's one using the Oculus Rift. So Oculus is, if you saw the hackathon, a lot of people were putting on depth sensor cameras. The Oculus is normally a VR experience. So this is a standard VR scene that we created using exactly the same open source toolkit. It lets you, just create a basic 3D model, the scene that you can look around in. But the Rift, usually you can't see out of it. It's VR, so it's very immersive but disembodied experience. You can't see your limbs and extremities. Using the open source toolkit and open web standards, we've made it so you can just strap any standard web camera on the front. I should draw some eyes on the little white tape there. But that's just, that's like a $25 webcam. You can strap it on the front, and you can do it with two, but you generally don't need to. This turns it from being a VR closed sort of system to an immersive environment where you can really see through into the world around you. And so I'll skip forward because we're running a bit short on time. But as you can see, I'm gesturing around. So this is just in a standard web browser. I just enable access to the camera, give it permission, and then turn it into the Rift mode, and it generates a stereo view. So I'm not seeing the black around it. Each of my eyes are just seeing those unique images. And so you can see the floating sort of content around there. And when I interact with that, you'll see it drops down a 3D model of a car. Now, I did it out in the park, one, because it was a bit weird and I like doing weird things. Two, is also because it wanted a scene in the background so you could see out of the windows of the car. But one of the problems with the Rift is it only does rotation around a point. It doesn't have any concept of translation in space. So the new version they've released, they've added that so they can do tracking, but you can do exactly that sort of thing as well. And then the last demonstration is showing a range of scenarios. And again, this is all just running in a standard web browser, but this is running on Google Glass. So we start with visual search. I can look at any image and I tap the side of glass, and that does a visual search. So we send that off to the server, look it up, and it goes, oh, okay, that's a car sharing service in your local neighbourhood. So it brings it back, and it then goes, okay, I'll show you where all the available car shares are around in this neighbourhood. So they're just geolocation markers floating around. I can look around, and as I'm looking at each one, they become the focus, and there's my zombie impersonation. Now, I challenge anybody to concentrate on content in glass and look intelligent at the same time. I think it's impossible. So when I tap on one, it brings up a menu, and I could, book the car or get directions. But here I just teleport into a street view kind of experience. So this is looking into a 3D panorama of that location, so I can see what it's like where that car is. And again, the glass experience is much faster than this. It's because of the screen sharing. So those are all examples of AR experiences running inside standard web browsers. So, oops. The key is that you don't have to go through all of those hurdles. When you share content that's the augmented web, you just share a link, and that, social media is the best way to share that sort of content. People tap on it, and it just works. So let's look at how big the market is. If you look at the AR market today, these are the stats that you can just go and check on the Play Store. So I'm just looking at the Android slice alone. Geneo's got about 500,000, Wikitude's got 1 million, and Layo's got 10 million. So some of them have done a really good job with OEM distribution. But if you look at Chrome and Firefox and the web browsers that really support this, there's 160 million of those distributed already. So it's a massive addressable market. But if we look at how big the total market is, including desktop and then these sorts of devices as well, it's already over 1 billion installed so far. And the projections are that it'll be over 3.9 billion by the end of 2016. So this is by far the largest content consuming audience. They already browse and experience this sort of content, and they'll just be able to tap on links and just experience it. So this is by far the best, quickest, and broadest market that you can, create your content for. So really we're about where AR was in 2009. This is a letter that Ori wrote in 2009 when Apple had locked down the camera access. So we were still trying to get from the Android platform into the iOS platform. And this open letter really, tried to get Apple to do that. We're in the same situation. Apple don't support WebGL or the camera access on iOS at the moment, but I'm pretty confident that over the next 12 months that's going to change. So that's my summary of where we're up to with the augmented web, and I hope that changes your view of what's possible in a web browser and how you'll probably be creating and distributing your AR content over the next couple of years. Thank you very much.
Okay, so as the next speaker sets up, any questions for Rob? We have a question up front. And if you want to, Rob, you can hang out there at that podium to answer questions.
Thanks. Just a quick question about one of your slides.
Yeah, sure.
You had a slide where you showed 500,000 for Geneo, 1 million Wikitude, 10 million LayR. Are those? What are those?
If you go to the Android Play Store, Android provides the number of installed, like the installed base. So how many people have downloaded and installed that application, and you can check those numbers for yourselves. So. Yeah.
Okay, thanks.
Yeah, cool.
Okay.
Cool.
Is this a straight HTML5 implementation, or do you require a plugin?
No, so it's all open web standards. Now, HTML5 is a fuzzy term. So iOS claim they support HTML5, but they don't run these extra standards. So it's kind of like HTML5 Plus. It's the very latest web standards, but it's all open web standards, no plugins.
Just a quick question about your Oculus Rift hack demo there. You were accessing a web page. It looked like the Rift was wireless.
No. So the Rift was plugged into the normal laptop experience. So it's got the connector box.
Okay.
And the view, I was just capturing what was on the screen there, but I was seeing basically a web page presented to me.
Got it.
Yeah.
Thank you.
Cool.
All right, we have time for one more question.
So for the live flow from the webcam from the device, so is there any, what is the performance?
It's really good. So that's one of the things is people think the web isn't very performant. JavaScript can now perform as well as compiled C++. So, and we've still got a whole range of optimizations to go through. The image tracking that we're going to be releasing this year runs on the GPU, so it's really optimized and really fast. And that's just using WebGL. WebGL lets you now access the GPU on the devices. So we really shouldn't be thinking of web browsers as slow, clunky, page-by-page sort of things anymore. They are raw stream processing applications, and they're getting faster.
Okay, so to clarify, so when we talk about 4G or Wi-Fi connection is fine, but what if it's kind of downgrading, low speed connections?
So you can do completely offline experiences, so all the content is cached, and so you might charge it up at a Wi-Fi hub, and then after that it's all just running like a native app offline.
Okay, thanks.
Thank you very much.
All right, thanks a lot, Rob. All right, and then last up,